Okay. Okay, so this morning the lecture will be on logistic regression with multinomial outcomes. Okay. So the objective of the lecture or the module is number one, to understand the concept of logistic regression model to analyze data with polycotomous or multinomial outcome. So you can call a multinomial as polycotomous. Number two, to be able to estimate parameters of interest, um, which in our case are the beta coefficient, the standard error, the 95% confidence intervals. Um, those are the things lah. 3 or 4 things only lah. To be able to make inference based on the uh, model, and then to be able to predict the outcome based on the model, and to be able to perform model checking. So if you remember, most of the task for us, I mean for the course, includes number one, do estimation, which means we estimate beta, standard error, usually beta and standard error lah. Okay, maybe log likelihood and things like that. And then after that, we do inference, where we look at the p-value, where we look at the confidence intervals. Okay, because inference is a process of transferring your results, or making um you know making inference lah on the population of interest, because estimation comes from your data, but inference will be where you infer your result to the population of interest. And then based on the model, you can do prediction. And in logistic regression, the prediction usually include one, getting the probability of the outcome, and number two, getting the predicted class of the outcome. Model checking for logistic regression, for polycotomous outcome, is a little bit what we call tedious. Not that it is very difficult, but you have to do multiple assessment like binary logistic regression. We'll come to that later. So the motivation of the logistic regression for multinomial data is because of this data, because of these conditions. One, we have a data where the outcome of interest is in multinomial format. It means that the outcome is categorical, and the categories are more than 2, 3 or more. So Uh, People call this as multinomial data. Some call this as polycotomous data. Some call this as polytomous data. They are all the same. They have more than two categories, okay, three or more. So what we are going to learn or do uh, for such data is that we are going to use what we call as multinomial logit model. Last semester we used logit model, but for this one, specifically for a multinomial outcome data, we will use a model called multinomial logit model. It is an extension of the um, binary logic model. Right, so this is an extension of logistic regression, and we call this as multinomial logit or multinomial logistic regression. The difference between logit and logistic is that logit is a model to obtain the log odds, whereas logistic model is a model to obtain the probability. Okay. One of the categories of the outcome variable will be the reference category. In binary logistic regression, the reference category will always be the one that is coded as 0. Okay, as 0. But that depends on the software. The software, can allow any choice of of the group. Okay, so be careful when you deal with categorical outcome. You have to make sure which is the correct reference category. I've seen a few cases where people got confused and the reference category were not the one that they are interested to compare. So each of the other levels is compared with this reference. Okay, in binary logistic regression, this is quite straightforward, but again, remember which is the reference category. So the choice of reference category can be arbitrary, right? So it is at the discretion of you, and also check the software how they deal with the reference category. This is the log odds of a single multinomial logit model. Okay, where we have only one independent variable x x1, and in this case we have three categories of outcome: 0, 1, and 2. So in this case the reference category is 0. So in multinomial logit model, first we compare the log odds of 1 against 0. Then we compare the log odds of outcome 2 versus 0. How about 2 versus 1? Nope. If you want to do 2 versus 1, then you have to do some manipulations of coding so that 1 will become the reference category. So you have the intercept alpha 1 and intercept alpha 2. because this is the intercept for logit 1 and this is the intercept for logit 2. This is the regression coefficients for logit 1 and this is the coefficient for the logit number 2. So if you have 4 categories, then you have uh, natural log of probability of disease equal 3 given x1 divided by probability of disease equals 0 given x1 equal alpha 3 plus beta 3 1x1, so on and so forth. And similar to logistic regression, binary logistic regression, you can convert the log odds to odds ratio. Um, Odds ratio for level 1 where you compare between x equal 1 to x equals 0, assuming the independent variable is a categorical variable. So you have probability of disease equal 1 given x equal 1 divided by probability of disease equal 0 given x equal 1 divided by probability of, sorry, this should be d. Okay, disease equal 1 given x equals 0 and probability d equals 0, x equals 0. When you do this, you know that the alpha 1 and alpha 2 will cancel each other. And because of that, you can just exponentiate the value of beta. Okay, so because of this formula, the odds ratio, this is odds number 1, this is odds number 2, odds divided by odds equals odds ratio. Okay, so and and because you divide a1 alpha 1 plus beta 1 1 1 x 1 0 here, so alpha 1 will cancel each other, so that's why you don't have alpha 1 here. And then you exponentiate, okay, the log odds. Now you move to the right hand side and you exponentiate it, and then you'll get the odds ratio. Similarly for the um, level 2 odds ratio level 2, where the outcome is 2 versus 0. Okay, this is an example from Hosmer Lemeshow book, Applied Logistic Regression. Hopefully you have lah this book. Okay, you can buy the original one lah. Very nice book. Okay, very informative. So in this table you have logit 1 and logit 2, where you have constant for level 1 and constant for level 2. You have independent variable history of violence. Okay, and you have the log odds value, coefficient, standard error, relative rate ratio, and 95% confidence intervals. So even though we calculated, I mentioned odds ratio, but Hosmer Lemeshow recommended to use the term relative rate ratio. Okay, relative rate ratio.
Kayaknya relative ratio dengan odd ratio ni can be used interchangeably lah.
Yes, yes, yep, betul. Jadi,
Thank you, bro.
so for example, if you look here, so this is the log odds, right? So the estimated log odds So the sample here are adolescents, and the data is looking at the factor or the risk factor for placement in the facility. You know, you got some what we call um, adolescents with problems, so they are looking at what factor that affect the placement of this problematic adolescents, whether they are going to stay at intermediate facility or whether they are going to stay at home or whether they will be staying at um, mm, I forgot one more. The placement category. There will be a longer notes, okay, for this slide. So I suggest that you refer to the longer notes after this. Okay, this is a slide just to to what we call describe briefly what we are going to do for this topic. So the estimated log odds among adolescents with history of violence. Violence is coded as 0 and 1. So if the adolescent has, or if the adolescents have history of violence, the log odds to be placed at intermediary facility 1 is -1 plus 124 minus 1.124 plus 0.5811 times 1, which is minus 0.543. So if the adolescents have been shown to be violent before, so the odds to be placed at intermediate facility, the log odds was minus 0.543. If they don't have any history of violence, the log odds was minus 1.124. Okay, because now 0 refers to non-violence adolescent. So if we change this, if we convert log odds to odds ratio, then you just exponentiate the value of the log odds or the beta. So we know that adolescents with history of violence, okay, the odds to be placed at the intermediate facility was 1.79 times higher than adolescents without history of violence. Okay, this is comparing between 1 against 0, placement 1 versus placement 0. Okay, I think I'm not sure. I've got to check back the book. What would be the placement for 0 and placement for 2? But one of them is placement at home, meaning that they don't have to be at intermediate facility lah. It is not a prison. It is like, tempat tahanan sementara. And then house placement, duduk dekat rumah, and the other one is, I'm not sure, I've forgotten the other one. So they are comparing uh, what factors that leads for this problematic adolescent to be placed. Where are they going to be placed if they have this risk factors? So this what we interpret here is only for logit 1, right? So you have to also interpret logit 2. And so for logit number 1, we compare placement 1 versus placement 0. So logit number 2 is placement 2 versus placement 0. Okay, right. Okay. I should have put another interpretation here, but I think I can leave that to you to go back to the book and try to figure out how to interpret logit number 2. And again, you have to look at the software or the table to see what would be the reference category. Okay, don't just assume it is 0, because some software don't do that. Okay, they will use the bigger value in your code as the reference category, so be careful. So these are the estimated values. Okay, the coefficient, the standard error, the RRR, the odds ratio, those are all the estimated values. So next we look at the inference. When we talk about inference, we usually look at the hypothesis testing and 95% confidence intervals, or just confidence intervals, because it is not always that we look at 95% confidence interval. Sometimes we look at 90% confidence interval, and sometimes we look at 99% confidence interval. So it is not always 95% confidence interval, but most software will use the default at 95% confidence interval. It means that over a long run of similar uh, investigations or similar studies, the true value will fall uh, in 95% of 100 experiments. Okay. Um, so this is you can calculate the 95% confidence interval for the log odds, and you can also calculate the 95% confidence interval for the odds ratio. It is quite easy. You just take the beta value and then plus 1.96 times standard error of beta, and then beta hat minus 1.96 times standard error of the beta. And once you got the value here, then you exponentiate. Do not exponentiate this direct. I mean, do not what we call exponentiate this value direct for the 95% confidence intervals for odds ratio. Okay, you have to use this formula first, get the lower bound and the upper bound of the beta or the log odds, then exponentiate it for odds ratio. All right, and then when you develop your models, it is not always that you get the best model at one shot or one try. So most of the time it is not possible. You have a few candidates model, so to choose which model is better for you or more useful for you, then you need to do comparison between model. So when you want to compare your model, you can use likelihood ratio test. Okay, and the formula for likelihood ratio test is this: LR test equal minus 2 of the natural of the log likelihood for the reduced model minus minus 2 log likelihood of the full model. Full model means the model that have more covariates, and the reduced model is the model with lesser number of covariates, the smaller model lah. The full model is the longer or the bigger model. and this follows chi-square distributions. You need to get the degree of freedom, and from there you can calculate the p-value to show if there is a difference in the a significant difference in the likelihood between the two models. If they are not different, then you can take the simpler model. If they are different, usually we use p-value of less than 0.05, then you can choose the bigger model or the full model as your model of choice. You can also look at the word test. The word test is this one lah, the p-value, I mean the coefficients divided by the standard error, then you got the word value, the z value, and that is the word test. Okay, so you just simply look at the value here, whether the p-value is significant or not for the predictors. However, the limitation of word test is that it is significantly affected by the number of sample. Okay, if you have a small sample in your data, and then the word test easily changed, so they are not that stable. Okay, in terms of model building, this is what Hosmer and Lemichaud suggested. Okay, but this is not the only way of building your model. Okay, but however, this is one of the ways. So according to Hosmer, first do univariable analysis. Okay, first do univariable analysis, and then you select variables with p-values of 0.25 or below for the next step. Okay, um look also for categorical covariates, whether you need to recategorize them or not. Sometimes, for example, you have variable ethnicity, and maybe in that variable you have very small number of certain ethnicity. So should you combine that group with a larger group to increase the sample size for that group? You have to think about that. Okay, so after you have performed the univariable analysis and identify those with p-value of less than 0.25, then you include them uh, in a model. So now you are fitting multivariable model, and then if you have a covariate A, B, C, D, E, then you might have a few combination like A, B and C, A, D and E, A, C, D, E, so on and so forth. So to compare between these models, you can use word statistics or likelihood ratio. Of course, the LR test is much better lah. And if, for example, you have a model with covariates A, B, C, D, and suddenly you decide that you want to drop D. Okay, you got covariate A, B, C, D, and now you are thinking, can I drop variable D? Okay, what you can do is you can drop variable D. However, check also the coefficient. Okay, the beta value uh, in the model with A, B, C, D, and in the model with A, B, C only, and see if the coefficient change by more than 20%. If they change more or greater than 20%, it means that removing the change significantly or quite meaningfully the value of other variables. So it means that variable D might be a confounder. And you know that a confounder should stay inside the model. They should not be excluded. This is based on Hosmer-Lemaitre, right? So there are, long discussion on what we mean by confounders and how to retain, how to remove them. But this is a very simple recommendation by Hosmer. And then check linearity of logits for numerical covariates. Do this only for independent variables that are numerical. Okay, they must follow the assumptions of linearity on logits. To check this, we have a few methods. The two most commonly used methods are one by using design variables. That is, you categorize the numerical covariates into four categories, and then you plot the coefficient against the outcome and see whether they are linear or not. Secondly, by using fractional polynomial methods. This is recommended by I forgot his name. I contacted when I was in UK, and I asked him about these fractional polynomials, and he was very happy lah. Dia kata, oh, ada orang Malaysia call dia tanya pasal fractional polynomials. Okay, so but the thing is that it is not easy to do this linearity in logics checking. So most of the time, I think 95% or more than 90% of the time, people don't mention this. People don't show this when they report their logistic regression results. Okay, but it is actually important. Okay, it is actually important. And then Hosmer said after you have done this, you are happy now. You got, let's say you got covariates A, B, C, and E. Then now you can add interaction variables in the model. And according to Hosmer, you can choose based on clinical importance, or you can do exploratory. It means that you do interaction between A, B, A, C, A, E, B, C, B, E, and C, E. Exploratory kind of approach. Then look at the p-values and set the p-values. You can set the p-values at 0.05. But in one example, actually Hosmer used the p-value of 0.1 even. Anything below that value, you can include in the model. So this is what we call preliminary final model. And then now you assess the model fitness. And in multinomial logistic regression, there is no package at the moment that can do this automatically. What you need to do is you need to run binary logistic regression separately, between 0 and 1, 0 and 2, and do model assessment for each of the separate binary logistic regression. So it is troublesome lah. It is troublesome. So yeah, but at the moment there is, to my knowledge, a package that can do this right away. What you need to do is to separate this into binary logistic regression and do a model assessment. So again, the model assessment, if you remember logistic regression.
Prof,
Yep.
sebelum tu, nak yang Prof mention, kita kena buat individual binary logistic tu, so kita punya outcome tu kita still maintain yang reference level tu yang zero tu lah, ataupun nombor lain lah. So
Yeah,
maknanya
yeah,
1 to 0, 2 to 0 gitu.
yeah. And then covariates tu letakkan covariates yang final tu lah. Independent variable yang final tu. A, B, C dengan E. Okay. So, and okay, Hidayat.
Boleh.
Right. So, how to assess your model is in logistic regression, there is the overall model fitness. Okay. For example, looking at the ROC curve, looking at the area under the curve, looking at the what we call confusion matrix or the classification table kita panggil kan, computer panggil confusion matrix, which includes sensitivity, specificity, true positive rate, true negative rate, PPV, NPV, so on and so forth. What else? One, two, yeah, right. So you can also look at the Hosmer Lemeshow chi-square test and Pearson chi-square test. That's for the overall model fitness. And then I think at this stage, as students in the RPH in the epidemiology, you have to go beyond this. Okay, that would be the overall model assessment. If the model is fit, or all right. If the model is not fit, then you have to identify where are the problems in your data that make your data not fit. So because of that, you have to look at individual diagnostic assessment of the model. It means that you have to look at each of the observations in your data set. So this is where you look at the uh, the value of delta chi-square, delta deviance, leverage, um, delta beta, and so on and so forth. Because now you are looking at the possibility of outliers and influential observations. So you have to get the values and do some plots to identify which of the data points or the observations that give problem to your model. Okay, right. When you want to do this in R, okay, when you want to do this in R, um, I recommend that you always have a workflow in your brain lah, in your mind, and usually this is the workflow. Read your data, okay, read your data, and then do some data exploration, and then build your model, assess your model, and between explore, build, and assess, they can happen many times. Okay, you explore, you build, you assess, then you need to go back and explore and build again and assess, and then if you are not satisfied, go back again, explore your data, build a new model, and assess your model again. After you are happy with it, then you can make prediction, and then you need to be able to interpret. And again, if you work in R, always start with a new project. Okay, the general packages, number one is Haven. If your data is in Stata or SPSS, or SAS format. Okay, if your data is data in CSV, then you can use readr package. The foreign package, I don't really recommend it because the foreign package can only read Stata data up to version 12. Okay, that's what I know lah. Okay, and then tidyverse package for doing exploratory data analysis and making plots. You can use summary tools to to get the exploratory to do exploratory data analysis. Summary tools, I think is quite a useful package for EDA. Or specifically for analysis of multinomial data, there are three packages actually. One is VGAM. I think VGAM stand for vector. Forgot already. Vectorized Vector Generalized Additive Model ke apa, tak ingat dah. Okay, VGAM, NNet, and MLogit. The one that I bold down there too, MLogit. And I think maybe the most useful, this is where last time I checked, this was last year lah. Okay, so I'm not sure whether there are newer packages that can do multinomial data. So package VGAM, and the function is VGLM. The other package is NNet, and then the function in the package is Multinom. What I observe is that okay, results, if you run VGLM or Multinom, they are similar. Okay, they are similar. But Multinom does not provide p-values. Okay, does not provide p-values. If you run Stata, you can just write the code that this code. You can run Stata. This is a Stata code to run multinomial logistic regression. And in my opinion, the results displayed by Stata actually looks nicer lah. It looks cleaner, easier to look at compared to results from R. Okay, so you see later. Okay, there is a package called mlogit in R. However, this requires the data to be in white format. Okay, in white format. In fact, I have the example in the practical note. Okay, right. So this is going to be my last slide. I have two other notes. One is the longer version lecture notes. Okay, the longer version of the lecture notes, and the other one is the notes for practical. Okay, notes for practical. I'll share with you later, and or maybe I'll put this inside the eLearn portal. Based on my experience lah, okay, I think um, I think students still need need to do more practicals to get comfortable with the analysis. Okay, so I hope you can do practical as soon as possible. Find the data. You can use data in R, or better still, if you have data, your own study or your friends data that you can use to apa ni to practice. It doesn't have to be very good data lah, but data that you can run to estimate, to infer, and to predict. Okay, do quick analysis. Don't have to do a very long analysis like in my notes. Okay, just do very short EDA, and then just do a very short estimation, inference, and probability. I think that's good enough. But do many times lah. Okay, do many times. You can use our Studio Cloud or you can use our Studio Desktop. Assess your model. Try to interpret. Okay, try to interpret because the results in R are a little bit confusing. Sometimes you can make mistake. Okay, so be careful. Okay, and please upload your results to our Studio Connect. Tak ada deadline lagi ni. Bila tak tahu nak diberi deadline. So the practical, the notes for practicals actually is available on YouTube. Tapi what I'm gonna do is I'm gonna put both the lecture note and the slide, the lecture notes and the practical notes inside the e-learn.